In this video, we're going to use Descartes' rule of signs. And it says, using the function f of x equals 7x to the fourth plus 2x cubed plus 4x squared minus 6x plus 5, in Descartes' rule of signs, what are possible combinations of positive, negative, and complex zeros? So what we want to do is we want to look at, for f of x, we want to basically, for Descartes' rule, we count this number of sign changes for f of x, and we do the same thing for f of negative x. So f of x, we're going to say count all sign changes, and those would be the positive roots. For f of negative x, we're going to count all sign changes. And that will be the negative roots. And then anything that's left, so out of the 4 roots that you could get, anything that's left would be the complex zeros. So let's go ahead and count all the positive sign changes. So we're going to count the positive sign changes, and we have one change from 4x squared to negative 6x. So we have one of these. So I'm going to say for f of x, one sign change. And then we're going to do f of negative x, so that'd be 7 negative x to the fourth plus 2 negative x cubed plus 4 negative x squared minus 6 times negative x plus 5. So that gives you 7x to the fourth. This time it's minus 2x cubed plus 4x squared plus 6x plus 5. So we count the sign changes. That'd be 1, 2. Actually, up here I screwed up. That's it. 1 sign change, 2 sign changes. So this should have been 2 sign changes, because I went positive, negative, positive. So 1, 2. This is 1, 2, and we only have 2 sign changes here. So we have 2 sign changes for f of negative x. So let's take a look at our options here. We could have 2 positive and 2 negative. That's one option. We can't have 4 positive because we have 2 sign changes for f of negative x. So, and we have to have 2 negative. This means 2 negative roots. This means 2 positive roots. So this doesn't work. 0 positive, 4 negative. Nope, we have to have 2 positive because we got 2 sign changes for f of x. We could have 2 negative, 2 complex. Yeah, we could have that, right? Because we could have 2 negative and then 2 positive complex numbers. And we could also have 4 complex numbers, because the complex numbers could have 2 positives and 2 negatives. So this is also an option as well.